It could be an asteroid hitting the Earth. It could be a new virus, climate change, nuclear war.
The world has grappled with the far-reaching consequences of pandemics throughout history, each time facing an invisible enemy that knows no borders. As we continue to monitor and respond to terrestrial threats, it's prudent to explore the possibility of a threat from beyond our world. What if the next pandemic originated in space? While this notion may seem like the plot of a science fiction thriller, it's not entirely out of the realm of possibility. In this episode, we will delve into the intriguing concept of pandemics of cosmic origin, considering the potential sources, consequences, and the steps humanity might take to prepare for and mitigate such an extraordinary scenario. From meteorites carrying extraterrestrial microbes to the uncharted territory of interplanetary contamination. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space, and beyond, consider subscribing. The biggest problem with space explorations: there are approximately 100 to 200 billion galaxies within the observable universe. While we have not yet discovered life on other planets, there exists an immense number of worlds where life could potentially thrive under the right conditions. This is why NASA and other space agencies take the issue of potential contamination between our planet and other celestial bodies very seriously. The last thing we want is to accidentally introduce life among the stars when we are striving to explore and understand it. Scientists refer to this as forward contamination, where tiny terrestrial organisms from Earth could inadvertently hitch a ride on equipment that hasn't been thoroughly cleaned, potentially arriving on other planets, moons, or asteroids. When it comes to missions to places like Mars or Jupiter's moon Europa, where the conditions for life are theoretically possible, contamination protocols become even more stringent. Panspermia. Another type of contamination, known as backward contamination, is also a concern. In this scenario, we might unintentionally bring back extraterrestrial microbes from space, or these life forms could naturally spread throughout the universe by hitching rides on meteoroids, comets, or even space dust. This concept, known as panspermia, could even offer an explanation for how life initially traveled across the universe and arrived on Earth. However, it's essential to recognize that just as life can expand its reach, it also has the potential to cause harm and destruction. Tesla in space. When Elon Musk launched his Tesla into space, it's likely that he didn't take the best precautions to prevent interplanetary contamination. As more and more commercial space launches occur, this lack of protection against contamination could become the usual practice. The truth is, it's almost impossible to avoid contaminating space entirely, and it may already be too late. For instance, consider the case of a privately launched Israeli lunar lander that crashed on the moon in 2019. It was carrying thousands of tiny organisms called tardigrades, which are known to survive extreme conditions like freezing temperatures and high radiation. These tardigrades could be on the moon right now, potentially causing unintended consequences. Some microorganisms can thrive and change in conditions similar to microgravity or the permafrost on Mars. This means we must take every possible precaution to prevent forward contamination, which is the spread of Earth organisms to other celestial bodies. Now let's talk about how to avoid forward contamination. We should begin with thorough chemical cleaning and heat sterilization of our spacecraft to eliminate any life on their surfaces. It's crucial to stay far away from this process because it can be hazardous. As we plan human missions to Mars, we need to establish strict rules about where we can land and explore long before we actually go there. We should designate specific exploration zones where contamination can be controlled. Before venturing into other parts of Mars, we must implement even stricter precautions. However, what's even more concerning is not forward contamination, but the risk of accidentally bringing extraterrestrial life back to Earth during outer space missions. These microbes, if introduced into our biosphere, could pose existential threats to various organisms, including ourselves. This is something we should be genuinely worried about as we explore the cosmos, finding life on Mars. The chances of discovering life on Mars, whether in the form of fossils or living organisms, appear quite slim. However, there is a possibility that certain life forms could survive in areas on the planet with water. These Martian organisms might share a common biological origin with life on Earth, which is intriguing but potentially perilous. The reason for concern is that these extraterrestrial microbes might find Earth to be a welcoming environment, increasing the risk of them becoming invasive space microbes that gradually take over our planet. These invasive organisms could lead to the extinction of many plant and animal species, including humans, because they could function as pathogens. Organisms like parasites, fungi, or viruses that require a host to thrive, which could be you. Because these space parasites are so different from earthly life, they could be resistant to your immune system's defenses. The notion of silent, multiplying space microbes that could infiltrate our bodies and eventually pose a catastrophic threat to Earth may sound like the stuff of science fiction, but in the realm of space exploration and scientific caution, such scenarios warrant serious consideration. The hypothetical situation described above underscores the imperative need for stringent rules and protocols when it comes to handling biological samples from outer space. The universe is really big, and there are many things we don't know about it. One of the things we're curious about is whether there might be life on other planets. So, we've sent spaceships to places like the Moon and Mars to collect things like rocks and dirt to help us figure this out. But there's a problem. When we bring these things back to Earth, we might accidentally bring along tiny things from space that could make us sick. Imagine if there were invisible germs from space that could get into our bodies and make us really sick. That would be a big problem. To make sure this doesn't happen, we have to be very careful when handling these space samples. We can learn from what we did during the Apollo missions when we brought back moon rocks. The astronauts who went to the moon had to stay away from other people for a whole month when they came back just to make sure they weren't carrying any space germs. We also looked at the moon rocks very carefully to make sure there were no signs of life or dangerous stuff in them. Even though we didn't find any life, we were really careful to make sure Earth was safe. If we're going to other places like Mars, we should do the same things. We should be really careful and treat the samples as if they could be harmful until we're sure they're safe. We should keep them in special containers on the spaceship and make sure they don't get out until we know they're okay. We should only let scientists study these samples when we're completely sure they won't hurt us. This way, we won't accidentally bring strange creatures or dangerous things from space to Earth. But if we're not sure if the samples are safe, we might have to take a big step and clean everything really well while still in space. This might sound extreme, but it's important to make sure we don't bring any harmful space germs back to Earth. In the end, even though the idea of space germs taking over Earth is mostly a wild idea, it reminds us that space exploration can be risky. So we need to have strict rules and be very careful to protect our planet and everything on it when we explore the universe. By following these rules, we can make sure that searching for knowledge in space doesn't accidentally hurt our home Earth.